first thing we want to do, or first thing I always do, is split apart the number from the variable. So we're going to do the cubed root of 125 times the cubed root of x to the fourth. How can I break apart 125? 5 times 25. What is my index? 3. So I need 3 numbers that are all the same being multiplied together. Do I have 3 numbers that are all the same? No.
You can't.
I can get there. How do I get there?
25 is square root of 5.
Yes, 25 is 5 times 5. Or another way that I could write this exact same idea is the cubed root of 5 cubed, because I have 3 5s all being multiplied together. What is the cubed root of 5 to the third? Yeah, so I'd have 5 to the power of 3 divided by 3, because I divided by my index. What is 3 divided by 3? 1. I get 5 to the first power, or just 5. All right, so I get 5 from that first cubed root. And then x to the 4 divided by 3 divided by my index. Does 4/3 come out to be a whole number? Does 4/3 come out to be a whole number? No. 4 over 3 is equal to what as a mixed number? 1 and 1/3. Yes. So I can rewrite this as 5x to the 1 and 1/3. So I have x to the first times x to the 1/3. I break apart that mixed number. How can I rewrite this in radical form? Yes. So I have the index of 3. This is going to be 5x, and then the cubed root, not of 3, the cubed root of x. My apologies. If we have something to the first power, we usually don't have to put the little 1 there. You can if you want to, if it makes you feel better so that you see those exponents there, you can put them there. That's not wrong. But they're not necessary. They're not required. Let's look at number 2. Number 2, once again, I'm going to break this up. So I want the 4th root of 32 times the 4th root of x to the 8th. 4th root of 32, I'm looking for 4 numbers that are all the same underneath the radical being multiplied together. What multiplies to give you 32? 4 and 8. Do I have any numbers under the radical that are the same? No. Can I continue breaking things down? 4 is 2 times 2. 8 is 4 times 2. What's my index again? Index is 4, so I need 4 of a kind. Do I have 4 of the same thing underneath the radical? What do I have? I have 3 that are the same. Am I done being able to break things down, though? All right, so the 4th root of, I've got 2 times 2. What can I still break down? 2 times 2 again, that's my 4, times 2. So far, so good? Do I have a group of 4 2s? Yes, I do. Right here. So I could write that as 2 to the 4th times 2, all underneath my 4th root. I can split that up and give them each their own radical. So 4th root of 2 to the 4th times the 4th root of 2 times the 4th root of x to the 8th, just representing this different ways. How can I simplify this piece right here? Divide. 2 to the 4 divided by 4 would give me what? 2 to the first power, which is just going to be 2. I can't do anything with this 4th root of 2 because I can't break down 2 any more than it already is. What about this? What can I do with this last piece back here? Divide x to the 8 divided by 4. 8 divided by 4 is going to be what? Yep, so I have x squared. So this right here is fully simplified. There's nothing wrong with that answer. It's just not in the order that we normally give it. So it's like someone said a sentence to you and you understood what they meant, but they said it really awkwardly, so it sounded weird. What order should I put this in so that it's easier to read? Yep, whole numbers, anything that's not underneath the radical goes first. So 2x squared, and then what? And then the radical, 4th root of 2. Fully simplified and in the correct, easier to read order. What's my index on the radical here? What's the index on the radical?
4.
4. What's the radicand? What is the radicand? I thought I heard somebody say it, but it was really quiet. 2. Radicand is the part that's under the radical. So in my final answer, I have an index of 2 and an index of 4 and a radicand of 2. What about up here on number 1? What was my index? 3. In my final answer, what is the radicand? X. The part that's under the radical is the radicand. I bring this up because today what we're going to focus on is learning how to add, subtract, and multiply with radicals. For adding and subtracting, things like terms always come up when we're talking about combining things in algebra with adding and subtracting. The way I know if two radicals are like terms is if those two radicals have the same index and the same radicand. So if they have the same index and they have the same thing underneath the radical, then I can combine those coefficients together. Those will be like terms. Grab your books for me. We're going to start off on page 335. 335. All right. We're going to learn how to add and subtract these together. First thing we need to do is fully simplify each term. So I'm looking at this one right here. I'm going to leave the 6 out in front alone for right now. And then they're breaking down that 45x. They broke it down into something times 5x. What times 5x would give me 45x? Yep. So 9 times 5x. Similarly, we're going to come over here to the square root of 12. We're going to break that down. 12 is blank times 3. 4 times 3. And then I come over here to the last term. It's minus 3 times the square root of 20x. I'm not dealing with the 3 right now. I'm just looking at the part under the radical. I'm just looking at the radicand, and I want to simplify it. I can break 20 down into what times 5x? 4. Why do you think they broke them down this way? Why didn't they do 2 times 10 here? Why were they looking at 4 times 5? What's special about a 4 under a square root? It's a perfect square, right? 4 is 2 times 2, so I can write that as 2 squared. What is the square root of 4? 2. So this is 2. And then I've got my 5x still under the radical. That just came straight down. Same thing with my middle term. We have the square root of 4 and the square root of 3. They wrote square root of 4 as 2 squared. You guys agree that 2 squared and 4 are the same thing? What is the square root of 2 squared? What is the square root of 4? 2. We bring this part straight down. Getting over here back to the first term. I kind of worked my way backwards here. 9 is the same thing as 3 squared. So I have 3 squared under the radical, and I have 5x under the radical. What is the square root of 3 squared? What is the square root of 3 squared? What is 3 squared? 9. What is the square root of 9? 3. What should I put as the radicand here? 5x, yes. All right. Do you guys see how this 6 is not under a radical? 6 is not a radicand. 3 is not under a radical either. I'm going to take those pieces and multiply them together. It's only going to distribute to the part that's not under the radical because it is not under a radical. So what do I get when I multiply those two together? What do I get when I multiply the 6 and the 3 together? I get 18 plus 2 square root of 3 minus, and then I've got the same kind of thing back here. Neither one of these are under a radical, and they're being multiplied together. What would that give me? 6. All right. I want you guys to look right here. I have 3 terms, just like I did that back at the beginning, but they've all been simplified now. They are like terms if they have the same index and the same radicand. Do we have any like terms here? Anything that has the same index with the same radicand? Which pieces are like terms? Well, 5x is my radicand. What is the whole term? I'm looking for things that are like terms, so that would have to be the whole piece together. Anything that comes in front of the radical would be the coefficient on that radical. What do you see in front of the 5x? 18. This term right here, this is one term. It has multiple pieces in it, but it is one term because there's no pluses or minuses in there. Do you see another term here that has the same index, same radicand? Because I do. Yes, minus 6 square root of 5x. These are like terms. Same index, same radicand. Same index, same thing under the radical. I'm going to combine those two together. So I have 18 square root of 5x's. And I have minus 6 square root of 5x's. We're going to look at just the coefficients. So I'm just paying attention to the 18 and the minus 6. What do I get when I put the 18 and the minus 6 together?
Wait, together?
Yep. We're going to combine them together. 18 and minus 6. 12. I have 12 square root of 5x. Why didn't I make this 14? Doesn't have the same radicand. Has the same index, but does not have the same radicand. These two are not like terms. Same index with same radicand, I can combine the coefficients out in front by adding or subtracting them, depending on the signs between them. If it is not the same radicand, or if it's not the same index, I can't put them together. I can't treat them like terms. What questions do we have before we move on? Okay. Let's look at our next example. Same page, just a little further down the page. Example number 4. What operation do we have going on between these pieces? Multiplication. We want to multiply these two radicals together. So first I look for anything that is not under a radical. Do we have any pieces that are not under radicals? We have a 4 and we have a 3. We're going to multiply those together. 4 times 3 would give me what? 12. What's the index on my first radical? 5. What's the index on my second radical? 5. If the indexes are the same, then I can take the parts under the radical and I can multiply them together. And then they did something weird. They started breaking things down at this point. They didn't even multiply the negative 10 and the 16 together. They took negative 10 and they broke it down to be what? Negative 1 times 2 times 5. They broke that negative 10 out into those pieces. And then they just recopied the x squared and the y to the 6th. Let's take the 16 and see if we can break that one down, because they didn't break that one down for us yet. Let's break it down as far as we can. What numbers multiply to give you 16? 4 and 4. Is that broken down as far as we can get it? 4 squared, we could write it as 4 squared. Can I break it down more, though, before I talk about 4 squared? Yes, 2 times 2 times 2 times 2. You're absolutely correct. That would be 2 to the 4th. That's what I'm going to put right here. 2 to the 4th power. So I have 2 to the 4th, x to the 4th, y to the 4th. All right, so then they did some reshuffling. They moved some things around. How many 2's are being multiplied together underneath this radical? I've got 2 to the 4th right here. Are there any other 2's under the radical? There's a 2 by itself. This would be 2 to what power if it's all by itself? 2 to the 1st power. If I have 1 2 right here that's being multiplied, and I have 4 more over there, how many do I have altogether? I have 2 to the 5th power. So these two pieces together are why I have 2 to the 5th power. They brought the 5 straight down. Then they did something weird with the x's here. I have x squared and x to the 4th. If I have 2 x's right here and I have 4 x's over there, how many do I have altogether? I have x to the 6th, right? Did they write down x to the 6th? What did they write down? They have x to the 5th, and then they have an x all by itself. Does that still add up to 6 x's underneath there? I'm curious. Why do you think they didn't write x to the 6th? Why did they do x to the 5th and x? What's my index again? 5. So they made this exponent match that index. And then we have these y's here. I have y to the 6th and y to the 4th, which means how many y's altogether? 10. All right, now they broke down and gave everybody under here their own radical, and we need to simplify this now. The 5th root of -1. What number multiplied by itself 5 times would give me -1? What number multiplied by itself 5 times? -1. The 5th root of -1 is -1. What about the 5th root of 2 to the 5th? 2. Because we'd have 2 to the 5 divided by 5. That's going to give me 2 to the 1st power, which is the same thing as just 2. Can I simplify this one at all? The 5th root of 5. Can I simplify the 5th root of 5 at all? Nope. So I'm just going to write that down underneath here. What is the 5th root of x to the 5th? X. What should I put as the radicand for this next one? What should we put here? X. Bringing this piece down. What is what? What is the next one? What goes on this blank line here? Y squared. Tell me how you got y squared. This guy right here, we divide the exponent, 10, by the index. That's how we got the squared right there. All right, we are almost done with this one. Look right here on this next to last line. Tell me everything that is not under a radical. 12, 2, -1 I heard. All of those are not under the radical. X is not under the radical. And y squared is not under the radical. So we're going to move all of those to the front. What happens when I multiply these numbers together? I get -24 and then xy squared. So what should I put under the radical as the radicand? What are the pieces that are still under the radicals? 5 and x, yes. Here and here. There's one last problem that we're doing together today. It's on the next page. Page 336. They've got so much of this problem done for us already, but I want to make sure that we know where these pieces are coming from and why. The area of a triangle is equal to 1/2 the base of the triangle times the height of the triangle. So here's this triangle-shaped pennant right here. Do you guys see the triangle-shaped pennant? Okay. This is what they have decided is the base. It does not matter when you're doing this on your own if you switch the base and the height. Here's the base. Here is the height. So we need to substitute into this formula 1/2 base times height. And they're starting that right here. So they've got the 1/2 there. What's this 3 square root of 8 plus 4? What is this? Where did it come from? From the triangle. Which piece of the triangle? What are we calling that part? The base. And we need to multiply the base by what? By the height. So let's fill in the height right here. What are we filling in for the height? 7 square root of 8 plus 6 square root of 3. Beautiful. We're not going to deal with the 1/2 right now. I just want to deal with the parts inside parentheses. We're going to use the distributive property here. So first I'm going to take this 3 square root of 8 and I'm going to distribute it to the 7 square root of 8. That's what they're showing right here. They didn't actually combine them together yet. They're just showing that we are multiplying those parts together. And then they took the 3 square root of 8 and they distributed it over here to 6 square root of 3. That's what they're showing right here. What else do we still need to distribute? What else do we still need to distribute? The 4. We need to take this part right here and distribute it to the 7 square root of 8. That's right here. And then we have to take the 4 and distribute it to the 6 square root of 3 right here. So one piece at a time now. We multiply the numbers that are not underneath a radical together. What do I get when I multiply 7 and 3 together? 21, that's right here. And then we take the parts that are underneath the radical because the index is the same. It is a square root, it is an index of 2. The parts underneath the square root, we're going to multiply together. So I have 8 times 8. That would give me 8 squared. Coming over here to the next piece. With the yellow box around it, what are the numbers that are not under the radical? 3 and 6. And when I multiply those together, I get what? 18. Then we multiply the parts that are underneath the radical together. What are my radicands? What are the things underneath the radical? 8 and 3. And when I multiply those together, I get what? I get 24. Coming over to the next term. What are the pieces that are not under the radical? 4 and 7. I multiply those together and get what? 28. Are there any radicals to multiply together? Nope, we just bring down that square root of 8 right there. And last but not least, we get to our very last term. What are the numbers that I'm multiplying together here that are not under the radical? 6 and 4. When I multiply those two together, I get what? I get 24. And then we bring down the square root of 3. So far, I'm still ignoring that 1/2 out front. We're not going to deal with that 1/2 until the very, very end. All right. So I'm wanting to make things that are easy to take the square root of. 8 squared is not going to be hard for me to take the square root of. What is the square root of 8 squared? 8. So this is 21 times 8 right here. 24 we had to take and break down. What's 24 divided by 6? 4. So this is 4 times 6. But they wrote 4 as 2 squared. Why did they write 4 as 2 squared? Yes. What is the square root of 2 squared? 2. So that would be 18 times 2. They took 8 and broke it down. How did they break this down? It's what times what? They wrote it differently, but what is 2 squared? So they wrote 4 times 2, but then they rewrote the 4 as 2 squared. Because as we've already discussed, 2 squared, or square root of 2 squared is just 2. Did they break down that last square root at all? No, why not? Why didn't they simplify the very last square root? Already fully simplified. What is my very last radicand? 3. How does 3 break down? It doesn't. It's just 3 times 1. All right, let's multiply each of these pieces together. You're going to need to grab a calculator for me real quick. I need to multiply 21 and 8 together. What is 21 times 8? 168. I need to multiply 18 and 2 together. 36. I need to multiply 28 and 2 together. 56. And what do I put on this very last blank line? 24. Now I'm going to take a 1/2, this 1/2 out at the front that we hadn't done anything with until now. We're going to distribute that to each of these pieces. Again, only the parts that are not under the radical, because 1/2 is not under the radical. What is half of 168? 84. So I have 84 plus, what is half of 36? 18. What is half of 56? 28. And half of 24? 12. It's right down here. How many terms do I have? How many things do I have that are separated by pluses and minuses? 4 terms. Look at each one of those terms. Does my first term have a radical in it? No. Does my second term have a radical in it? Yes. What is the radicand on my second term? 6. Do I have a radicand of 6 in any of the other terms? No. Does my third term have a radical? What's the radicand on my third one? 2. Does it have a like term anywhere in here? No. What's the radicand on my last term? 3. Does it have a like term in here anywhere? No. So that would be my final answer. Yes, sir.
I mean, couldn't you add more stuff? That's the final answer.
That's our final answer. That is big and long, though, isn't it? If somebody said the area of this triangle is 84 plus 18 square root of 6 plus 28 square root of 2 plus 12 square root of 3, do you have any idea how big that actually is? Right? Like if somebody gives me that answer, I'm like, I have no idea what that means. If I'm at the hardware store and I'm trying to buy something, nobody is going to describe area like that. That is fully simplified and that is precise. It did not need to be rounded. But if I'm going to go out and try to talk about this at a store or with another person, I'm probably going to give a decimal approximation of this. I want to try to find a decimal approximation. Yes, sir.
Could this school, if you could do the base height of the school, would it have an answer like that?
If I were to do the base and height of what?
This school.
This school? I mean, well, the school is more of a rectangle shape than a triangle shape. It really depends on our measurements and how we're measuring and how precise we're being. For this one, when they measured that pennant, they came up with some very strange measurements. I got to be honest with you guys here on this one. As far as the book goes, are they showing a skill that we need, distributing with these radicals? Yes. Did they pick out a very good application for it? Is this a very realistic story problem? Probably not. The skill is important. How they chose to represent it, I'm not so sure I agree with. I do want to practice popping this in the calculator, though, and getting a decimal approximation. If you do not have a calculator near you, raise your hand so I can bring you one. Everybody should have a calculator. Thank you.
Thank you.
You're welcome. Anybody else need a yellow calculator? Welcome. All right, we're going to practice typing this in together. All right. Oh, you need one too. Mariama, can you hand me that yellow calculator next to you? Thank you, ma'am. Does anybody else not have a yellow calculator? I want to make sure everybody's got one. So we're going to practice typing this into the yellow calculator to get a decimal approximation. All right, I'm going to go through this, typing it into Desmos, because this is the biggest thing I got up on the screen that's similar enough to your calculator. What's the first thing we're typing in? 84. Put 84 into your calculator. What came after the 84? Plus 18, right? 84 plus 18. And then we need a square root. How do you do the square root? Second and x squared. So put your square root in. 18 square root of what? It was 18 square root of 6. If I keep typing right now, everything else is going to end up under my radical. You got to use the arrow to get over, get out from underneath that radical.
Wait, my 18 looks weird. It's like, oh.
Let me see. Ah, you guys used the, how we do the cube roots. We want a square root, so second x squared. So go back and delete that out. You want a square root, so second and x squared.
So 84 plus 18.
All right, so I have 84 plus 18 square root of 6. I've arrowed over. What do I put in next? Plus 28 square root of 2. What do I have to remember now? Press the arrow. Plus 12 square root of 2. 3. Sorry. Square root of 3. There we go. Hit enter. You should get a number that's very similar to that on your screen. 188.47 if we take it out to 2 decimal places. 188.47 would be our decimal approximation here. 188.47. Important takeaways from today. Can you type it in your calculator? This is how you're probably going to make applications of this in the real world. Can you type it into your calculator? Second big takeaway from today. How do I know if things are like terms and they can be combined if they're radicals? Yep. Underneath the radicand is the same. What else has to be the same? The index. If that's true, then I can combine the coefficients out in front with adding and subtracting. We can use the distributive property too. We can single distribute or we can double distribute. Pieces that are outside the radical get multiplied together. Pieces that are underneath the radical get multiplied together if, what's the big if on multiplying? What has to be the same if I'm going to multiply the parts under the radical together? Has to have the same index. Yes. 8.5 homework is due on Monday. We are back in McGraw-Hill. Everything so far has been in McGraw-Hill except that one worksheet. Please make sure that you turn in your bell work today. You've got the rest of the class time to work on your homework.